rational functions. So this is 3.7. So 3.4 has more theorems about real zeros and rational zeros. This was a optional topic. That's why I only wanted to show you the most important one. And 3.5 talks about, 3.6 talks about complex numbers with 3.6. And my department decided that we have to move on to 3.7 as the last section. Okay, rational functions. In this class, we can only deal with 3 types of rational functions. Anything beyond that, it's not under our control at all. So I'm going to call them 3 types of rational functions, and I'm going to call them type 1, type 2, and type 3. Nobody calls them type 1, type 2, and type 3, but I have to give them a name so we can differentiate among those 3. So type 1. I'm going to give you a few examples, and then I'm going to ask you something. So here's one. Here's another.
This is type 1?
Yes. Then I'm going to give an example of type 2. And another example of type 2. And then I'm going to give an example of type 3. So these are type 1, these are type 2, and type 3 is this. Or this. And now let's discuss all 3 and see what is specific to type 1, what is specific to type 2, what is specific to type 3. We are limited in this class to these 3 rational functions. Good. So let's look at type 1. Can anyone say, oh, I think type 1 does this? Or by comparison. So type top and bottom. Excellent. So degree n over degree n. That's it. Type 1 requires both top and bottom to have the same degree. Awesome. Type 2. Very good.
It's the degree on top is less than the degree on bottom.
That's it. So degree n and the bottom degree definitely greater than n, not equal to. Perfect. That's it. And the third one.
Degree on top is greater than the degree on the bottom.
By exactly 1.
By exactly.
This is by exactly 1. So if the bottom is degree n, what is the degree at the top? That's it. Mandatory by 1. If it's more, our hands are tied. We can't do anything. Ready? Okay. Now, we need to look at a few more things that were not valid for polynomials. And then, if you remember, I said the first graph will take 20 minutes. The second will take 3. The third will take 1. So bear with me. I have a lot to say here. Okay, so what we know from before, from polynomials, we know that, so graphing a rational function. N, I'm sorry, it's my N. So they're all little n. They're all n, all degree n. We normally, yes, we normally don't talk about degree m. It's always degree n. Yeah, sorry about that. Good. Graphing a rational function. What do we know from before? We know in the list domain. We know range. I'm sorry, not yet. Range at the end. We know domain, right? The second one was X-Intercepts. Third one was Y-Intercept. Fourth. Say it again.
Symmetry.
Yes, very good. 5. End behavior. I want to add here, of course, multiplicities. And multiplicities. 6. Correct. But range is a requirement after I graph it, if I'm asked to, otherwise. There is one thing that we discussed in polynomials that does not have anything to do with this, with the rational function, which is number of terms. Number of terms before was degree minus 1. There is no degree for a rational function. So we can talk about number of terms. Turns. We cannot talk about number of turns. Okay? There is no degree here. Good. Now I have to add more to the list. Here is one. Vertical asymptotes. Item number 7. Horizontal or not both. If a function has a horizontal, it will not have this. If it has this, it will not have this. Or slant asymptote or asymptotes. Item 8. Behavior near vertical asymptotes. I want to draw your attention to one thing. 5 and 7 should be together. It's safe to have them together. This is it. I know it's a long list. It's not going to be difficult. Just follow with me. Ask questions. Stop me if you have anything. But if you pay attention, it's not going to be difficult. Okay. This we know, this we know, this we know. Multiplicities we know. Symmetry we know. And behavior we need to talk about. Vertical asymptotes, horizontal and slant, and behavior. So I'm going to talk a little bit about these. And then we'll start our first exam. As you know, the rational function is not a friendly function. Why? It's not like polynomial. Polynomial functions are friendly. Exactly. It has restrictions on the variable. Where will the restrictions on the variable come from? Right, because the denominator cannot be
0.
right. What happens when the denominator is 0?
That's fine.
It's undefined. Awesome. Over there is a vertical asymptote. So when the function is undefined, there is a vertical line at that point, at that x value, that the function will never cross because it's undefined. So what are the options? Assuming that I am the vertical asymptote, what are the options for the function? Infinity, negative infinity, or infinity, infinity, or negative infinity, or negative infinity, infinity. because the function is undefined there. And that is the vertical asymptote with the behavior near the vertical asymptote. So once I identify that the function is undefined at x equals 2, it will take another 30 seconds to identify whether it goes this way on this side and this way on this side, or this, or this, or this. So again, these two go together. This one with this one. So that's what a vertical asymptote is. So let me give you just a couple of examples here with graphs. So there is one graph that we looked at, the simplest possible rational function. What was it? We graphed it in the long list of functions. That's it. And at that time I said, we are going to talk about this extensively. Bear with me and believe me that the graph of this is this. What is the vertical asymptote of this function? I need a line.
X equals 0.
Thank you. X equals 0 is a VA. Why? Because this function is undefined at 0. Now, how do I find the behavior? The behavior near the vertical asymptote means this. Does it go to positive infinity? Does it go to negative infinity? Does it go to positive infinity or to negative infinity? It could never cross it. Always remember, no function can cross its vertical asymptote because it's undefined. Okay, so now how do I know this? Here's how I do it. Give me a number close to 0, not 1. 1 is not close to 0. Something very close to 0.
0.1.
0.1. What is the sign of 1 over 0.1?
Positive.
That's why it goes to positive infinity. Give me a number on this side, close to 0.
Negative 0.1.
What is the sign of 1 over negative 0.1? That's why it goes to negative infinity. It's a blink once I know what I'm doing. Okay, now let's talk about these two. This does not happen for polynomial functions. Why? Because polynomial functions either do this, or this, or this, or this, right? There's nothing else. But this function can do this. Look at it. And that will be called a horizontal asymptote. What does this mean? As x decreases towards negative infinity, the function values get closer and closer, closer and closer to a number. That number is the horizontal asymptote. On the other side as well. They don't have to have the same asymptote, however. In this class, they will have the same asymptote. But in the next one, they may have two different horizontal asymptotes. One here and one here. But in this class, we're sticking to those that have the same horizontal asymptote on both ends. So as x approaches infinity, the function values get closer and closer to a number, and that will be the horizontal asymptote. What is the horizontal, which is also the end behavior? What is the horizontal asymptote here? That's it. And now you know everything about rational functions. So let's start with type 1. If anyone can give us a type 1 so we can graph it. Type 1 requires a little bit of effort, not too much. Type 2 is much easier than type 1, and type 3 is the most involving. And you see, bless you, you'll see in a minute why. So if you want, bless you, if you want to pick on page 289, I want to draw your attention again. I'm not against the book at all. I think it's not a bad book. But this is unacceptable to me. I mean, I would have to read 3 pages to come up with a graph. Totally unacceptable. The information is not summarized, is on 3 pages, and it doesn't give me a chart. I can't follow anything. I have to write it and summarize it myself. So again, if you understand the method, I'm fine. But without a summary, I think it's... Okay, on page 290, anything you want from 43 to 64 for now. 43 through 64. One more time on page 290, but I would like type 1 first. Can anyone give us a type 1? Which one?
44.
44. 1 minus 2x, f of x, 1 minus 2x divided by 2x plus 3. And this is 44. I changed the name from r whatever to f of x. Now, you can choose the order you want here, but one of them you can't choose. You can do these in any order you want, but the first one has to be the first. Every time I'm asked to graph a function, I have to start with its domain. Yes, I'm sorry, yes. Very good. So can anyone give us the domain of this function?
Negative infinity to negative 3/2, negative 3/2 to positive 7.
We've seen this before, right? Once you complete the chart, one thing that does not fit here is the symmetry. But once you complete everything in the chart, you're done. And you can graph. Okay. So I know the domain. I know that this function is undefined at negative 3/2. We know that. Okay. Then immediately you will have to tell me what x equals negative 3/2 will mean for this function.
That's going to be the asymptote.
Vertical.
The vertical asymptote.
Very good. That must be a VA. Then you will immediately say to me, left and right I'll have infinity. But what I don't know is what? The sign of that infinity. So once I know that this is a vertical asymptote, negative 3/2, I know that left and right I have to have infinity, but I don't know which sign. Okay? So this is negative 1.5. I'm going to plug in negative 1.4. Negative 1.4 times negative 2 is a positive number. So the top is positive. Done. 2 times negative 1.4 does not cover 3. It's smaller than 3.
Right.
Top positive, bottom positive. What is the sign of this?
Positive.
That's it. Now I'm going to plug in negative 1.6. However, negative 1.6 will cover the 3. So this will be negative. What is the top? Negative times negative, positive plus 1. So positive over negative. What is the sign on the other side?
Negative.
So I'm going back to my list to see what I accomplished already. Here's what I accomplished. This, and this. Already, I have these 3 done in a blink. Why? Once I determine the domain, I know where the function is undefined. Once I determine it's undefined, I know it's a vertical asymptote. Once I know it's a vertical asymptote, the sides have to be infinity, and I have to find the sign. Just like that. Good. X-intercept. How do I determine the x-intercept?
Set y equals 0.
Very good. When is a fraction 0? Only when the numerator is 0. Very good. So this means 1 minus 2x equals 0, which means x equals? Very good. Here's 1 over 2, and here's 0. Careful where we put it in the chart. It has to be in the right spot. Good. Now I want the y-intercept. What do I have to do in order to determine the y-intercept?
X equals 0.
Good. Awesome. So look what I do. This is 0. This is 0. What is the answer?
3/2.
Now about the X-intercepts. Do I have to talk about multiplicities? Multiplicity 1. So there is nothing special going on, right? So let's see what we have accomplished already. A function like this one with a vertical asymptote at -1/2 cannot be symmetric. It's not possible. So I will write f of -x for sure will not equal f of x. And f of -x for sure will not equal -f of x. Cannot be symmetric. With a vertical asymptote at -1/2, it cannot be symmetric with respect to the y-axis, and it cannot be symmetric with respect to the origin either. The only and the last step we need is the end behavior and the horizontal or slant asymptote. Let me come back here to make it very clear. From all three types, the only one that has slant asymptote is this. The only one with slant. Only type 3. That's the only one with a slant asymptote, and I'll explain when we get there. The only one with a slant. Good. So I would like to show you the theory behind it, not just give you, remember this, memorize this, okay? So I have this function. I will rearrange the numerator in descending order. So I have -2x over +1 over 2x plus 3. Now, please tell me, what is the degree of the top? I'm going to factor it out. What is the degree of the bottom? I'm going to factor it. And I know you will say, and rightfully so, wait a minute. X is not a factor at the top. How do you come up with this? Well, X is not a factor at the top, but as long as I have how many terms here?
2.
How many terms I have to have here? As long as this times whatever I write here is this, and this times whatever I write here is this, I'm fine. Okay. So what would I have in parentheses? That's it. Let's check. Let's check. X times -2 is -2x. X over 1 times 1 over x is 1. Perfect. What about the denominator?
2 plus 3 over x.
Agreed? Now I will simplify. And after this, I'm going to ask you a quick question. Oops, I didn't mean plus or minus. As you see, it's all about algebraic manipulations, really. When we talk about end behavior, what do we really look at? Not here, right? Not in the middle, right? Exactly, that's the word I was looking for. So it means that x is very, very small negative, or very large negative, or x is very large positive, right? That's what we're talking about. Here, it has no meaning. This is not the end behavior. The end behavior is the extremities. Good. So stay with me. If x is a billion, how much is 1 over x?
Very small.
Almost what?
Almost 0.
That's it. If x is negative a billion, what will 1 over x be?
Almost 0.
Right. So at infinities, how much is this?
Almost 0.
How much is this?
Almost 0.
So then at infinities, the function approaches what? Which is? That's it. That's the end behavior, and that's the horizontal asymptote. for type 1. In short, the leading coefficient, for the leading coefficient. But I just didn't want to give it to you. Hey, remember, go home and remember this, leading coefficient. This is how we do it in calculus. We factor out x, the degree, whatever the degree is, 2, 2, 3, 3, whatever. We factor it, and then all we have is just a thing. These must go to 0. 1 over x at infinities or extremities, this will be 0. So what is left is negative 2 over 2. Let's graph.
That's for type 1.
That's for type 1.
So that'll always be true no matter what the leading
If
coefficient
it's
is.
type 1, leading coefficient over leading coefficient.
It's the horizontal.
Always. And the end behavior. Okay. Before I try to graph this function like we did before, please follow me for a second. This function starts at negative 1. When x approaches negative infinity, the function values approach negative 1. So from negative 1, the function, I'm going to put an arrow. Function goes to negative infinity. On the left-hand side of the vertical asymptote. On the right-hand side of the vertical asymptote is coming from positive infinity. It crosses the y-axis at 0, 1/3. It crosses the x-axis at 1/2, 0. And it approaches negative 1. That's it. One more time. So from approaching negative 1, dropping to negative infinity on the left-hand side of the vertical asymptote, coming from positive infinity on the right-hand side of the vertical asymptote, crossing the y-axis, the x-axis, and approaching negative 1. Why? Because it's summarized in front of me. So from negative 1 down to negative infinity, down to 1/3, down to 0, down to negative 1. When I graph a function with asymptotes, I have to graph the asymptotes first. So let's start. First asymptote is the vertical one, negative 3/2, which is here. X equals negative 3/2. Then I have y equals negative 1. Then I plot the points I have. I have 0, 1/3. Then I have 1/2, 0. And now I follow my chart. My chart tells me what to do. So one more time. Let's do it together one more time. Do not be tempted to start above the y equals negative 1. Okay? So from approaching negative 1, comes down to negative infinity on the left-hand side of the vertical asymptote. That's what this says. Then on the right-hand side of the vertical asymptote, I start from positive infinity. It crosses here, and approaches negative 1 from above, negative 1. This is the graph of function f of x, negative 2x plus 1 over 2x plus 3. Yes, with the graphing calculator, let's see what I mess up now. So in y equals, you must put parentheses around the top, and you must put parentheses around the bottom. So let's see what keep an eye on what I type in here. So negative 2x plus 1, close the parenthesis, divide by parentheses 2x plus 3. The graphing calculator will not graph the horizontal asymptote by itself. So I have to graph a new function. Which function is that?
X equals
You're talking about the vertical, which is not a function. I'm talking about,
negative 1.
that's it, negative 1. Let's go to zoom 6. And let's see what happens. I don't know how to do this software, how to put a vertical asymptote, but if you have, your calculator should show the vertical asymptote. Yeah, there is a way of putting it in. I'm not sure. I don't remember how to do it. Does anyone remember? You can YouTube it or something, and it will show you the vertical asymptote. I don't remember how to, on these new calculators, how to make the vertical asymptote appear. But you know it's there. We know it's there, correct?
Yes.
Yeah. Any questions on this? This is type 1. I do want to show one more type 1 before we move on to type 2. And I want to make one up. Let me see if one of the ones that I made up before is what I'm looking for at this point. No, I have to make up another one. Here's our f of x. X squared plus 3x plus 2.
Screen's kind of small. Yeah.
Oh, yes, of course. I'm sorry. Over x plus 1, x plus 2. I'm sorry. X plus 4, x plus 2. Okay. Is this type 1?
Yes.
Yes, because the degree of the top is, and the degree of the bottom is 2. Very good. Now I'm waiting for you to give me the domain of this function. We can make it a little bit more interesting, but it doesn't matter. I'm not going to change it now. I only wanted to change x plus 4 into x minus 4. But it doesn't matter. Very good. Once you do this, I know you know what you're doing and you don't have to write it again. So once you fill up the chart, or your own chart that you invent, whatever works for you, I'm fine. Good. Before we conclude, because I know you're expecting me to immediately write x equals negative 4 VA and x equals negative 2 VA, right? Because that's what we just discussed. Before we do that, let's factor out the top. Because there is a catch here.
That's plus 1 and that's plus 2, so that's plus 3.
So what will you do immediately once we already stated the domain? I already stated the domain. Negative 4 cannot be in the domain. Negative 2 cannot be in the domain. So now I'm allowed to simplify the function. What would you simplify it by? Right? So then the simplified form is x plus 1 over x plus 4. Agreed?
Yes.
Okay. X equals negative 2 is not a VA, but a hole in the graph. Because it's undefined. Still undefined. I can't change that.
Yes, what do you mean?
I'm not graphing this. Oh, I'm sorry. I meant without the W. I'm sorry. 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 I see. This is what I did. I'm sorry. That's what I meant. So negative 2 is still undefined because we're graphing this.
Right.
So, but now because x plus 2 went away, it's not in the function anymore. That cannot be a vertical asymptote. Only the factors that stay in the denominator are vertical asymptotes. So now I go back and I will say x equals negative 4 is a VA. It cannot be simplified with anything from the top. and it cannot go away, right?
Would you say before it can't be anything in the denominator? It can't?
If a factor disappears, that is a hole in the graph. It's not a vertical asymptote. But the factor that stays creates the vertical asymptote. Only that one. Or those ones that stay. Good. Everything else is the same. So can anyone give us the horizontal asymptote?
1.
That's it. Y equals 1 is the horizontal asymptote. So can anyone give us left and right of -4 initially? Right, but I don't know the sign. Very simple to find the sign. With -3.9 on this side. -3.9, negative. -3.9, positive. Negative of a positive is?
Negative.
That's it. With -4.1. -4.1 plus 1, negative. -4.1 plus 4, negative. Sign? Positive.
How do we get the horizontal asymptote?
Leading coefficient over the leading coefficient as we did factoring out x. Good. Let's plug in 0. What do we get? Very good. And I also want the X-intercept. When is a rational function 0?
Numerator is 0.
When is the numerator 0? Right. Can a function with a vertical asymptote at -2 and a hole in the graph at -4 and a hole in the graph at -2 be symmetric? No.
Now,
The-
for the symmetry, do we need to still do the f of x equals
As long as you write an f, yeah. I mean, just write it's not symmetric, and I'll assume you checked. But this is what I have to write.
Yeah.
Or you can just say a function with a vertical asymptote at -4 and a hole in the graph at -2 cannot be symmetric in any way.
Is it only ever symmetric if the horizontal and vertical asymptotes are the same distance from 0?
Exactly.
Okay.
Exactly. For example, we're going to get to the tangent function. Tangent function is that case. Yeah. Okay. I'm only missing one thing. Right here. I cannot put infinities. That's not a vertical asymptote. But I need this. So please plug in -2 in that. Not in this. In that. The top is, and the bottom is 2. That's it. That's the hole in the graph. -1/2. That will be that point. -2, comma, -1/2. -2 plus 1 is -1. -2 plus 4 is 2. Ready? When I graph a function with asymptotes, what do I have to graph first?
The asymptote.
Absolutely, that's mandatory. How many asymptotes do I graph? Careful.
2?
Yes. I graph y equals -4. I'm sorry, I meant x equals -4, of course. And I graph y equals 1. And now I have to plot -1, 0. And 0, 1/4. And the point -2, -2, comma, -1/2. Oh,
Just draw it in circle.
bless you. I said -2, comma, -1/2, but I graphed something else. Okay, ready?
Wait, what is that point? Next number, like above the
0, 0, 1/4. Okay, so let's take a look at the chart. Ready?
From one
From approaching 1
goes up.
up to infinity on the left-hand side of the asymptote. On the other side of the asymptote, it's coming from negative infinity. It goes through that open point.
Yeah.
It crosses the x-axis at negative 1, 0. It crosses the y-axis at 0, 1/4, and then approaches 1. This is how we understand the graph, not punching it in just yet. So let's graph it, and then we can check. So, as Paul said, from 1 going up to infinity. Here it is, no problem. Then it's coming from negative infinity. It hits this open point. It hits the x and the y intercepts, and it goes towards infinity. The calculator will not give you that open point. So that will not be useful if we don't analyze it and understand it. So we graphed f of x equals x squared plus 3x plus 2. Do not trust the calculator. Trust what you know first. Ready? Make sure you put parentheses around the numerator, parentheses around the denominator, and you make y equals 1 for the second function. So parentheses for the top, x squared plus 3x plus 2. You know me, I don't trust this, so I have to multiply those. So it's x squared plus 6x plus 8. So I don't put too many parentheses. And now I'm going to use zoom 6. So as we knew, it's coming from 1 going up. It's coming from negative infinity. Hits the open point, which is not here. Negative 1, 0, 0, 1/4, and then goes to positive infinity. So the only thing you can see that is when you go to second and table, and what do I put in?
-2.
Negative 2. And when I put in, what should I get?
Error.
That's what it is.
Yeah, but still practical.
Now you could go and zoom in the area at negative 2, and you will be able to see it. So in the viewing window, if I go to negative 2.5 and 2.5 and y minimum negative 1, let's say to 1, with a scale of 0.25, it should show something.
It's too complex.
It doesn't. So don't trust the calculator. Please don't trust the calculator. But we know it's an error.
Yep.
So there's no discussion there. I was hoping to see a blip or something in there. Nope, nothing. Okay, let's look at a quick one. 1 over x plus 1. Is this type 1 or type 2?
Type 2.
Type 2, very good. It is indeed type 2. Again, no one calls them type 1 and type 2. I do because I want us to understand what we're talking about. There is only a minor difference. Type 2 is always the easiest of the three. Can anyone give us the domain of type of this function?
This is not equal to -1.
When x is 0, what do we get?
1.
Good. Obviously, x equals -1 since the factor doesn't go away. What does this mean?
Vertical asymptotes.
Very good. Now I know infinities left and right. Can anyone give us a sign of those infinities? On the right, with negative 0.9. Negative 0.9, negative 1.1. Positive. And with negative 1.1,
Negative.
very good. Can this function be symmetric with a vertical asymptote at negative 1? There is no such thing. The only thing left is the horizontal asymptote and end behavior. Good. So I have to see what happens here. So put infinity in here, plus 1, and tell me where it's going. Where is it going? It's very similar to 1 over x. It's 1 over x plus 1 is the same thing. Where is it going?
It's smaller.
Which is?
Here.
That's it. This is always the case for type 2. That's it. Done. In this case, this is an overkill. We don't have to graph the y equals 0 again, but I'm trying to make a point so you don't forget. Y equals 0 is the horizontal asymptote. X equals negative 1 is the vertical asymptote. Well, let's look at the chart and decide where it's going. It's coming from 0, going to negative infinity on the left-hand side of the vertical asymptote. On the other side, it's coming from positive infinity. It crosses the y-axis at 0, 1 and going to, that's it. From 0 to negative infinity. From positive infinity. So this is 1 over x plus 1. Now I'm asking you this. What transformation is this on 1 over x?
Left.
Very good. Any questions?